you share about more how the traditional role used to look like and how the role looks like now?
So all the roles are getting impacted, not only the data, but the DevOps, data, AI world, and things are changing very rapidly.
But how much important is to know the system designing as well during this process?
You need to know how the things work, because LLMs or data engineering or database or even the software development lifecycle, that doesn't work in isolation.
Did this architecture change also brought some business benefit to the company?
Whatever you build should solve a real world problem.
Are these technologies are even helpful for the live streaming use cases, such as, for example, in India, we will take the example of the cricket. Welcome back to another episode of Techie Talks with Kuldeep. I am your host Kuldeep Singh. Today we are excited to have Mr. Deepak Sood joining us today to share about data engineering and AI world. Deepak, welcome to the show.
Thanks for having me here.
Deepak, before we start the conversation on data and AI, could you share about your experiences so far?
So hi, my name is Deepak and I have a total of 10 years of experience in the whole data and AI team. So I am currently working as a senior AI data and DevOps architect at Opstree Solutions. So I majorly take care of the three verticals, that is the data, the databases part, be it SQL, NoSQL database, then the data engineering, the whole event streaming pipeline, then data warehouses, and then finally the AI part, both traditional AI and Gen AI part. This is about me.
Data engineering you touched, right? And you started the journey from the databases, right?
Yep.
So which means the core database and the modern data warehouses
Yep.
are critical, but the role is also changing it to the AI world also.
Yep.
So could you share about more how the traditional role used to look like and how the role looks like now?
So as we are in software industry, things are changing very rapidly because of the whole Gen AI revolution from the 2022 when the ChatGPT came along. So all the roles are getting impacted, not only the data, but the DevOps, data, AI world, and things are changing very rapidly. So the main point for this, the whole current roles are to keep on learning. So keeping on learning, keeping up to date about things that are happening in your field is very important, especially in the Gen AI world, where new libraries, new frameworks keep coming up and they solve a real world problem that was not solvable before. If you have been writing a lot of code, now because of that framework and library, you don't have to write anymore. Also in the other part of the whole ecosystem, like the databases or data engineering, most of the code is being now written by the generative AI models, like Cursor, Windsurf, Bolt AI, Claude Code. So everybody in the software world is writing code via these Gen AI tools only. So things are changing very rapidly, and I would tell that keep on learning to everybody, and keep experimenting with new things, and just increase the pace of what you are doing.
So you are saying like the role traditionally which were more around the database administrator,
Yep.
the core data engineering, which are used to writing the ETL, ELT
Yes.
pipeline, and then the core also role of the machine learning and the AI engineer
Yep.
is also shrinking. Maybe the expectation is that one person knows each and every area.
Yes, that's true. So in the even in the machine learning world that you touched, so things are changing very rapidly because now the traditional machine learning models are not used anymore. Now new age Gen AI solutions are used a lot, and then of course you use these solutions instead of the old machine learning models. Because what happens in the machine learning world is you have to train all the models from scratch with your own data set.
Yes.
And it's a very tedious task. You have to do a lot of fine tuning, but with this new large language models, you don't have to do that anymore. And people are now okay using these hosted models also. They don't have to use smaller models on, there are, of course, these are available. So you can host your own models that are open source in your own environment, but those are not as powerful as the cloud hosted ones. So people are okay. So I'm working with multiple clients who are okay using directly the APIs from this OpenAI world, or Llama, Hugging Face, or Bedrock. So people are using these APIs to do all the experimentation. Then of course toward the productionizing one, they will see if they want to procure the GPUs and run all the models in there locally. But coming to the data engineering part, so data engineering part, it's all about writing the ETL pipelines, the extract transform load. And here you have to write a lot of code using PySpark. and that's where the large language models really excel at. So you can, I guess you can easily do 10x the work with, means you can increase your work by 10x using these tools, because they can debug, they can test your code, they can write test cases, and then of course it helps you, you don't have to do it through the whole documentation, which is an arduous task. So I would say, yeah, so this is it in the data engineering space. Things are happening very rapidly.
So one aspect, Deepak, which you touched is on the data engineering, right? I know it is very much important, but how much important is to know the system designing as well during this process?
Thanks, Kuldeep, for touching that up. So with all this advent of technology, fundamentals never change. So you have to now still focus on the fundamentals, and along with fundamentals, so system design is the part of the fundamental. You need to know how the things work, because LLMs or data engineering or database or even the software development lifecycle, that doesn't work in isolation. So you have to make sure everything is stitched together. If your front end is not working, your back end will not get data. If your back end is not working, the databases will not get the data. And same goes if databases doesn't have the right data set, right data quality, then nothing like data engineering can solve that issue from the core part. So we have to make sure that in the system design level, you create an architecture where the whole infrastructure is resilient, from the databases to data engineering, the whole ETL pipelines, and then how to create this data modeling architecture so that you can train those models whatever you want to train. So you have to make sure data quality is there, data quantity is there, and all this data is usable by the teams across. So system design is a core part, and I think and since the advent of YouTube, so a lot of good system design channels are available which people can use to learn this. It's they tell everything, and of course the democratization of knowledge is there. So fundamentals are very important, and any architect, or for a matter a data engineering data engineer, should know this paradigm, all the warehousing that are available, what are the architectures like Medallion architecture, like data warehousing concept like snowflake schema, star schema. So you need to know all these basics, so that you become a better developer, better engineer overall.
Agree. And I have learned it, right? So for example, the data engineering, why it is important. But could you share any practical example also where you have learned those skill set and applied at that brought, some significant changes in a client work?
Okay, great. So whatever I have learned on the job, because I think learning for the sake of learning doesn't work well until and unless you practice it. So you have to make sure whatever you learn, you do, because computer science is learning is only 10% of the part. The other 90% is just doing it, finding the errors, debugging it, solving it. That way you learn a lot. So you have to make sure you do the things. So coming back to your question, so I have used data engineering in a lot of projects. So one project that I want to touch is an IoT project. In IoT, there are tens and thousands of simple, smaller devices all over the country. So this is for a large IoT manufacturer. So they had this Raspberry Pis deployed all over the country, and they, at every 30-second interval, they are taking the power factor, they are taking energy, wattage, usage from this end devices and sending it to the cloud. So they want this data in real time, and these are MBs and GBs per second of data streaming that are happening all across. So here we created the whole data engineering pipeline, where how the data will come, how the data will flow through our cloud infrastructure, then how the analytics will perform. Because here batch processing will not work. Batch processing really work where, let's say, you have huge amount of data coming throughout the day, and then at night you can do those in batches. But here you want a real-time analytics of how your devices are performing, and also not only analytics, but how these devices will be controlled back. Let's say if some device is giving a lot of taking a lot of energy, maybe that device is going to get fire burned or not. So you have to real-time switch off that device. So you have to make sure your analytics are in place in the real-time pipeline. So here we have used Kafka. Kafka is a great event streaming platform that you can use, and it has on top of it Flink. Flink is a technology where you can write this ETL streaming batch streaming pipelines that do the analytics on the real time, and then of course the downstream doesn't have to do this in batches. So this was the whole pipeline that we have created, and this is the event streaming platform that I'm talking about.
Yeah, and the event streaming is very much important,
Yes.
specifically because the IoT being a very small memory related devices, right? It cannot withhold
Store.
so much of the data that it
Yes.
just needs to pass. So you added a layer in between where you are collecting the data from the IoT
Yep.
and sending it to the final destination.
Yes. So yeah, so here Kafka has topics and different partitions. So it has all the queues mechanism so that we don't overload the edged gateways also and our backend system also. So you can use Kafka to balance between the two. And of course, at last we had the data warehouse. Here at the IoT company, we use Druid as a main data warehouse. So Druid is also a large scale distributed data warehouse. It supports real time analytics, then it also supports hot and cold storage. So in IoT you have a lot of amount data that is coming up, and the old data is not significant enough. So let's say you don't need to know last 1 year data at a 30-second granularity level. So you need to do roll-ups that after the 1 year of data you will keep only 1 hour maybe the aggregated part, because at last if you have a huge amount of data the cost can increase. So it's around $400 per TB of data stored. So you have to make sure you compress the data, you move it to a cold storage. So let's say over the 5 years of data, you can move directly to a blob storage kind of thing in S3 or Azure storage. So you don't incur a lot of cost around the storage part. So we use Druid, which gives all these mechanical mechanisms: hot storage, cold storage, real-time analytics, batch processing. So that, and here also we explored. So we explored multiple warehouses because there are lots, and then drill down that, because there is a trade-off. Which one you want to use, you have to make sure that you use only that data warehouse which is solving your use case. So here we drill down to Druid, and then Druid is able to scale to a huge level now.
And I heard another term also, right? The GraphQL, right? This is something also useful in this scenario.
Yes. So GraphQL is a technology means a competitor to REST APIs. So whenever you create a REST API, the problem is that anything that you change, backend person has to go and change this API schema, API structure. And of course, if there are lots of things in your API structure, then your payload will be huge. And then maybe the front end using only two values from it and just discarding all. So it also increases the network bandwidth that is used. So here GraphQL comes very handy, where so Facebook is a big proponent. All the Facebook APIs that you use that are available from the Facebook are a GraphQL API, and that also for GitHub. GitHub also gives GraphQL APIs. So here you can pick and choose what you want. Schema doesn't change. You just have to register your model. You don't have to create APIs per se, at least the GET APIs. Update and post APIs you have to create, but GET APIs you don't have to create. And it's very easy to use. A lot of things are handled by the schema itself, and it's a great technology. So here at the IoT company that I'm talking about, we shifted to REST APIs, shifted from REST APIs to GraphQL APIs. And never we had a time that front end used to come and tell that create an API for this. So front end was a self-serve platform. Front end person can tell just add this model to your graph API. It's a one-line change, and he can use whatever he wants. So he doesn't have to backend doesn't need to do a lot of work to create the backend APIs. So it's a great technology. I would tell everybody to go and explore it.
Definitely, and I think it is a good area also, right?
Yes.
Which has simplified your architecture.
Yes.
Did this architecture change also brought some business benefit to the company? Maybe if you wanted to share like how earlier they used to do, after you implemented those changes, these are like the changes which they saw in the business outcome as well as on the technology side.
Sure, that's a great question. So what I am a big proponent of, whatever you build should solve a real world problem and a core business problem. Because let's say if you create a great product that nobody is using, then that's no use of the product, means because you cannot eat code, so that's a wastage of effort only. So I would say, so here at the IoT stage, what used to happen is, for each client that we onboard, like Domino's, we have to create a whole separate system for them. So previously, before the Kafka and Druid, so we have to spin up a new database for them, because we want the isolation, and the old database was not big enough or not heavy enough to solve both the clients. So it was a single tenant system. For each tenant we onboard, we have to spin up the whole infrastructure, spin up the front end, the back end, the security part, and then finally the databases and analytics part. So when we shifted to, so we wanted to move to a multi-tenant architecture.
Yeah.
So here we then used Kafka. So all the topics for each client are isolated. So we made sure the security is in place. And then finally at the data warehousing part, Druid performs this out of the box. So if you provide a client ID as the partition key, it keeps all the data separately in the database. And it's a multi-tenant system. So for each client we onboard, we don't have to spin up a whole infrastructure, which is a very arduous task for a DevOps person also. And then finally maintaining and those things we have to not to do. It's partition tolerance, it's highly scalable. And when we moved to this architecture, a lot of developer bandwidth got free, DevOps bandwidth got free, and we were able to scale this infrastructure to a huge level.
And one thing which you have touched also, and which I have also seen in your profile, is around, for example, like Prometheus, Elasticsearch, Kubernetes.
Yeah.
To me, these sounds like more for the DevOps part, but I'm sure you have used them in this project also to solve some of the business challenge, right?
Yeah. So I would say, since going back to the fundamentals never change. So fundamentals here are monitoring, observability, logging. So whatever you are doing in the backend, in the data engineering or in the AI world, you have to make sure you are able to see that. What is happening in the system? Is there any errors? And if there are errors, then go and see in the logs how to debug those errors. So logging is very important. Here where Prometheus, Grafana Loki comes in, where we use Grafana Loki or an ELK stack to keep all the logging in place, or a Prometheus like system where all the metrics from all the servers, like for the Druid. So until and unless you monitor how your Druid is performing, you will not be able to understand why there are errors coming up, or when you need to scale up the system, when there is lot of pressure in the system. You have to make sure your auto scaling is in place, because Druid or any horizontally scalable databases are for there. If you give it a metric, it should auto scale. It's not like that at daytime you have to scale it to a big infrastructure, and at night time you have to reduce it, because then it's a manual task. So we want there is a auto scaling solution in place. Here where metrics comes is, so in Kafka also, Kafka is also horizontally scalable. So what you can do is, in Kafka, consumer lag is a metric that you have to monitor very closely.
Exactly.
So if consumer lag increases, that is, you are consuming the messages that are coming in slowly than the messages that are being produced, then of course you have to increase the number of consumers that are there, so that you can process. Otherwise it can happen that you are processing very old data, and you will not reflect the real-time analytics or real-time business use case in the place. So all these are very important. Prometheus is a large data store for metrics storing. ELK stack is for logging. Grafana is for the dashboarding. You can create all the dashboard in Grafana. And then of course there is alert manager, where you can set up alerts. So you don't need to go and look into the dashboard all the time. That is also a very difficult task. So you have to make sure that whenever some out of bounds range comes, then you should get alerted that your server is down, or you are getting a high network connection, or your consumer lag has increased. So you can get alerted on the right time, and then you can take on the steps that are taken for the remediation part.
So Deepak, you have touched on the analytics part and how to observe it from the backend. But one thing which I see the similarity is, whenever I do also watch, for example, like IPL, etc. Are these technologies are even helpful for the live streaming use cases, such as, for example, in India we will take the example of the cricket.
Mostly what you need to do is, you need to warm up the state beforehand, because at that scale you will not get that much servers from the cloud itself. So we need to call AWS beforehand that we are going to host this much live event, and this is the infrastructure that is needed beforehand. So because they were on cloud and AWS, and of course they are multi-cloud, so we have to call GCP also that this is the amount of infrastructure we need, because you cannot provision it like 2 weeks before, then you will be paying a lot of cost, and you cannot provision at the time, because users come in very batches. So in like 1 hour you will get like from 0 user to a 10 million user base. So it's a very challenging task, and we need to pre-warm it. We have to work very closely with cloud vendors, and of course a lot of monitoring are in place. And then finally the fallback, that if the load increases, what should be stopped first, what are the critical services, what's the priority of the services that needs to be touched. So it's a very difficult task, but of course teamwork and good engineers solve this pretty seamlessly.
And I'm sure like it is not only the data component, it is also like the front end and the back end, how you are managing it. For example, you might have deployed it in the microservices architecture. So that's where I am assuming the Kubernetes also would have played a role in this.
Sorry, I didn't touch on Kubernetes, but Kubernetes is a very important piece of stack in the whole DevOps ecosystem. So, and of course, not in the DevOps, but in the data engineering backend world also, because everybody is moving to a microservices architecture. The problem with monolith was it's very difficult to scale. And you cannot scale individual components. Like for streaming, in streaming you really need to scale the streaming part, not the logging part. Most of the people have already logged in. So you have to make sure your streaming parts scale independently of the logging, so that logging you don't have to run like thousands of pods. You can run 10-20 pod on logging the whole that system, but in for the live stream part you can run thousands and thousands of pods. So you have to horizontally scale in that part. Here where Kubernetes excel, because here you don't have to manage individual nodes that are the EC2 servers or VMs of the world. You don't have to manage the VMs per se. You manage the applications, the whole shift right thing, that applications are being managed. You don't have to manage the infrastructure. You just say that how many pods you need to run and what are the priority of those pods, what is the requests and limits of that pods, and Kubernetes itself manage where this pod should be added in the VM part. There can be a place where 3 pods are running in the same VM, because it has the infra. Otherwise, in a monolith world, it will happen, not the monolith, but in a non-Kubernetes world, it can happen that one VM is using only 5 or 10% of the utilization. Other things are wasted.
Some are underutilized, some are overutilized.
So this Kubernetes really handles pretty well, and you can add node, remove node. So I have been using Kubernetes for past 8 years. It was at a beta time, then I started Kubernetes, and I have never gone back since. So all the infrastructure should be in Kubernetes. It provides resiliency. All the health checks are there. It provides, if a pod gets restarted, it automatically comes up. There are a lot of tooling provided around Kubernetes, so you don't have to do everything from scratch. So Kubernetes is a major part of the infrastructure, right?
And during this tenure, right, you have worked across multiple stakeholders, right, and across the different business domains also. So how did you work with like the different team members and the different stakeholder in these?
So yeah, that's right. So I have worked a lot with fintech domain. I have worked with IoT domain. I have worked with edtech, and right now I am working parallelly with e-commerce. Multiple e-commerces for a matter of fact. Then of course a big telecom giant. I am working with Apple also. So I am working with a lot of disparate business domains also. And the whole point, so software engineering is simpler. Once you get to this level, the whole challenge becomes how to learn these domains fast. So it's a very difficult task, but of course you need full ownership in this, and then work closely with the team to learn their lingos, learn their jargons, and then ask questions. So asking questions solves a lot of the problem. If you don't know something, just ask, because you are new to this domain, and people are more than helpful to tell you and teach you about these things.
So you are saying like it is not only the tech, but the importance of the communication skill also.
Yes. You need to communicate regularly with the stakeholders and clearly that what challenges you are facing. And of course, the team helps a lot. So, yeah.
And I'm assuming once you start communicating, this is where also you share how you can learn and grow. For example, one area you might not be knowing today, but tomorrow it is that, hey, you started knowing and starting learning around that.
Yes, that's true. And of course, team really helps, because you need to learn from other people also. You have to learn from others' mistake also. One life is too short to make all the mistakes and learn from it. So you have to make sure you read books, you watch a lot of YouTube videos where people are explaining the right architecture, right domain knowledge that needs to be done. So I think keeping on learning is a main part. And of course, I would also say note taking. So I am a very avid note taker. And I think since you will be working in this whole domain for a long time, you need to make sure that you keep remembering things. Means you have to write your own notes, because you cannot learn everything from scratch every time. So you have to make sure you keep on refining your notes, keep writing on it, keep reviewing it. That way you will be able to scale huge.
So these are some of the things which you require at a engineer level. But how, when when you are growing in the ladder, right?
Yes.
When you are becoming leader, and when I say the leader, it doesn't mean only like the CEO or something.
Yep,
It is, it could be that you are leader of a small team,
Yep.
but that small team needs to handle it.
Yes.
Right? I'm very much impressed the way you have scaled up, not only from the learning, but also I think your knowledge sharing. You are also doing like, the learning sessions with the team.
Yep.
You are also, conducting the offline sessions,
Yes.
presentation also for the client.
Yes.
So this area seems to be very much exciting.
Yes.
And I'm assuming the way AI is advancing, the
Yep.
data engineering and the core concept is also going to be much more important.
Yes.
So what advice you will give for an engineer who is just aspiring to become a data and AI engineer?
So that's a great question, Kuldeep. So that's why I am doing all these sessions, because what I lacked in my growing up phase, I don't want others to lack. So what happened? I need to learn all this thing on my own. Means there were not a lot of people whom I can learn from, apart from YouTube, of course. Therefore, I am giving this talks and presentation to other people so that they don't do the same mistakes. So I now think that if somebody would have told ki note taking is that important, then I would have taken started it maybe 2-3 years before. So I would not have to learn those 2-3 years again afterwards. So I think therefore I do these sessions. And coming to what things are needed from the for a growing engineer is, first thing is there is a T thing that you need to do. So in T you need to make sure the horizontal part, you need to have a deep expertise in one technology. So don't go with all the technologies you want. You need to only learn one technology, one area. Let's say you choose data engineering or a database or a backend. Stick to that and make sure you are very great expertise in that area. Then you go to the another horizontal part that you need. Now you need to know how this backend interacts with front end or mobile, how DevOps work, how data engineering works. But the core expertise should remain same. And then of course you can parallelly create multiple core expertise, but you have to make sure that your core expertise is there. You keep on learning those documentation, new technologies in your main core area, because so things are easy starting, but getting to an expert level takes time. So you have to do a lot of practice there. So I would say that this is the most important part: writing, learning, making sure you choose your core expertise, and then finally taking ownership and going deep into that expertise area that you choose.
Yeah. And also the understanding of the whole data life cycle, because it is not just something which you are taking care, hey, I just need to send this data from A to B, but just understand how this data is being consumed, who is using it, what they are doing, what's the use case which they have built over.
Yes, truly, Kuldeep. And I would also say now, since the advent of AI, especially the Gen AI field, we have to make sure you use Gen AI as much as possible. Don't try to outsmart AI itself. So don't get frightened by it. Don't make it a competitor. Make it a collaborator. So that's a very important task. So whenever I have something, so I don't solve the problem with my head. I go and try to use the AI intelligence to see how it can augment me. So use Gen AI in day to day, whatever the problems are. And so there are a lot of things happening in Gen AI. If people are using Gen AI, so we are doing a great work in Gen AI. So we are using RAG architectures, MCPs. So in MCP, so last week only I have seen a tremendous thing in the Gen BI world. So it's called Generative BI, where what you can do is whole data analyst role that was being done by a whole data analyst team, like creating dashboards, that now is reduced by, I would say, 100x. So now one data analyst can do 100 times the more output than when you needed a 100 people team. So generative BI is really solving the problem. We are solving this big with some of the biggest telecom giant, and there they have the use case where they want analytics from their database. Now what used to happen is you need a whole team to understand the database, because you have so many tables, so many columns. You need to learn those, and then you need to write the SQL query to get the right data, and then finally create. Then you will hand it over to the BI engineer, the business intelligence engineer, who will write Power BI or Tableau dashboard, who will create this dashboard. But now all this flow can be done in minutes. Means you can write a very complex statement. So one complex statement I wrote is, tell me the forecasting model, create a forecasting model to do a forecasting on telecom data, that how many users are going to be onboarded in the next few weeks. So it understood the schema of where the tables are, which columns and tables need to be used. Then it brought the data find out all outliers, removed it, then finally move to the coding part. So it written down all the data science code that are there, then ran that forecasting model, and then gave me a summarized thing. So doing this would require a 10 people team for 6 months, which I did in 6 minutes.
So Deepak, you are saying like you need to also start getting the business acumen understanding, so that you know where exactly you can use these use cases, where exactly you can use these technologies. And this is also becoming very much important.
Yes, Kuldeep. Right now, I would not say that coding is the core part that you should focus on, because this Gen AI, the chat GPT of the world, can write far better code than any developer that there is. So I would say ki don't go into the coding part. You need to know how to read the code, how to use the code. Because it right now also it writes in batches. So you have to make sure that batch you can take and put it into the your code, but focus on the problem solving part. How you are solving the business problem, how you are doing communications between the team, how to manage a team. That's where the next set of jobs are there, because coding is now getting democratized. Means now a product manager can write far better code than any software developer there is. So I would say key focus on system design, focus on the T part, that how all things are connected, how to create the pipelines end to end, how the data flows, and all those things, and then finally take the business problem and solve for those.
No, completely agree. And I think these are the skill set which everybody needs to learn. So great job, Deepak, for in sharing all the knowledge, all the learning which you have done. And I think over the year you have grown from a niche software engineer to a person who can lead the software as well as the data engineer and can create impact, because the scaling of whether it is IoT or the live streaming is not an easier task. Great job so far, and thanks for sharing your knowledge with us.
Happy to share.
That's it for this episode of Techie Talks with Kuldeep. Until next time, keep learning and keep innovating. Thanks for watching.